Welcome back to the CompTIA SecurityX CAS-005 series. In this session, we'll explore topic 3.4.2, which covers virtual hardware, host-based encryption, self-encrypting drives, secure boot, measured boot, and self-healing hardware. These technologies provide a strong hardware-anchored foundation for enterprise security. Let's start with virtual hardware. Virtual hardware refers to emulated physical components inside a virtualized environment, like a virtual machine. It allows organizations to deploy security-enhanced components without relying on physical devices. Examples include virtual trusted platform modules, virtual network interfaces, and virtual firewalls. Virtual hardware is especially useful in cloud and multi-tenant environments, enabling isolation between workloads and supporting microsegmentation strategies. Next, host-based encryption. This is encryption applied at the host level, such as a server, workstation, or laptop. It protects data at rest by encrypting entire drives or partitions, ensuring that even if a storage device is stolen or accessed offline, the data remains unreadable without the encryption keys. A practical example is Microsoft BitLocker for Windows systems or Linux Unified Key Setup, also known as LUKS for Linux servers. Host-based encryption is essential for safeguarding sensitive data on endpoints and enterprise servers. Now, self-encrypting drives, or SEDs. An SED is a storage drive with built-in encryption capabilities, typically using strong algorithms like AES. Unlike software encryption, SEDs perform encryption at the hardware level, which improves performance and reduces CPU overhead. They also enable fast cryptographic erase, where encryption keys are destroyed instantly, making data inaccessible without lengthy wiping procedures. These drives are common in compliance-heavy industries, such as finance and healthcare. Many manufacturers, including Samsung, Seagate, and Western Digital, produce OPA-compliant self-encrypting drives for enterprise use. Moving on to Secure Boot. Secure Boot is a unified extensible firmware interface feature that ensures only trusted and signed software can load during the boot process. This prevents malicious code, such as rootkits and bootkits, from executing before the operating system loads. For example, Windows Secure Boot validates digitally signed bootloaders and drivers. Linux systems also support Secure Boot using tools like shim and Mock Manager for compatibility with open-source kernels. Building on this, we have measured boot. While Secure Boot enforces integrity during the boot process, measured boot takes it further by recording cryptographic hashes of each boot component. These measurements are stored in the Trusted Platform module, providing a verifiable record of system integrity. This enables remote attestation, where a management system can verify that the device booted securely. In enterprise settings, Microsoft Device Health Attestation uses these measurements to confirm the trustworthiness of Windows devices. Lastly, let's discuss self-healing hardware. Self-healing hardware can detect firmware tampering or corruption and automatically restore itself to a known good state. It typically uses redundant firmware images or rollback features to recover without manual intervention. Examples include HP Sure Start, which automatically restores the BIOS if tampering is detected, and Dell Safe BIOS, which monitors BIOS integrity and rolls back changes if anomalies are found. This feature significantly enhances resilience against firmware-level attacks. In summary, these technologies, virtual hardware, host-based encryption, self-encrypting drives, secure boot, measured boot, and self-healing hardware, provide defense in depth at the hardware and firmware levels. They help organizations maintain trust in their systems, protect sensitive data, and recover quickly from attacks targeting low-level components. That wraps up this session. In our next lesson, we'll continue exploring advanced hardware and software security technologies. Don't forget to like, subscribe, and share if you're preparing for the CompTIA CASP exam or strengthening your enterprise security knowledge.